Hello, it's me, John, again. Okay, before we get to talking about honing the mains and the block and whatnot, I want to give you a kind of a glimpse of the car and the motor and what we're going to be working with. So anyhow, it's a this is a Bill Mitchell block. I picked up on eBay. Give you a glimpse of everything here. Bill Mitchell block. It's a it's a four. This is a 130 bore. Okay, so you got a 3.400 stroke on a 130 bore. It comes out to be 364.4 cubic inches. Okay, if you did the math on this particular motor that I'm building, it is a 302. And when I say it's a 302, it's because it's an 8.2 deck height. All right, 8.2 being from the center of the crankshaft to the deck of the block there is 8.2 inches, which is a 302. But because your normal 302 factory, cast iron block is 4-inch, or if you go 4-inch 030, 4-inch 30 thousandths, it'd be a 347. So because this bore is 130, 130 thousandths, and the stroke is 3.400, it's a 364.4. But we'll just call it a 364. So that's what we're working with. On the car, here's the car. I'm gonna try to maybe zoom this in and out. I get you. Good look at the car here. So it's a 1995 M Edition Mazda Miata. There's his M Edition. I picked this car up in California. At the time when I bought it, had 38,000 original miles on it. Never even seen the rain, but I drove it in the winter a couple times, just doing donuts in the parking lot or whatever. I put snow tires on it. So this is no trailer queen. I mean, the interior is nice. And the underneath of the car is nice. I had it oil sprayed the second that I bought the car. Before it even hit the rain, I had it oil sprayed. And then I replaced the convertible top because it had a plastic window, and this is glass. I did this top myself. The plastic glass rear window is awful. And then I did the wood grain on the interior. So it's got Whirlwood 4-piston caliper brakes, and the rims are by Ray's Racing. There's a 15x7 rim. They're monoblock forged rim. They weigh 8.8 pounds a piece. They're 15x7. They're the lightest rims that I know of in the world that are 15x7. Maybe they may make lighter ones, but I don't think they do. I think those are 8.8 pounds a piece. You can only get them in Japan from Ray's Racing or Volk, whatever you want to call it. But see, I got Toyo RA1s on it, 225, 45, 15s. That's what I run. So yeah. Anyways, I'm gonna go around the car and see if I can't. I gotta watch what I do with the license plates. I don't want to give you my license plates. So anyways, funny business going on. So there's the car here. Okay, now let's take a look at a modification here. Here's these are stainless steel headers. The car is complete stainless steel exhaust system all the way from the headers all the way to the back of the car is completely stainless steel. But here's where you cut out, the cutouts. There's the cutouts. You see that or not? That's right. Cut it out. This one you can't really see, but it's been cut out. I run air conditioning, power steering, cruise control. You can see the wires is a pretty big mess. But these headers are from Monster Miata. These are Martin. Martin has a guy that builds the headers for them. These are 1/2-inch flanges, 1/2-inch stainless steel flanges. These are stainless steel headers. Normally his headers don't come stainless steel, but if you ask him nicely, he might be able to make up a set for you. You know, custom, obviously, about $1,000. So the header has to be put in the car first. The steering rod has to go through the header tube like that, and then you wire it. This one kind of lays in there, but I wire it up anyways. And you can see that the AFR 205 has two sets of header bolts. They got the inners and they got the outers. And I set this up for the outers. You can see that where my bolts are is nowhere near my header tubes. Okay? See, the bolts are here. Way away from the header tubes. I don't have to struggle on putting my headers on. Alright? The AFR 205 heads come with two bolt patterns, an outer and an inner. And the inner ones are real close to the header tube, big pain in the butt. So you have to order these flanges. I'm going to tell you where. I'll tell you everything about it. So you're not struggling putting your header bolts in. Right? So, anyways, there. That's just one of the things. Now you look here. See, normally you got two copper tubes coming out from your heater core. Well, guess what? If you just touch these tubes, if this was the heater core coming out and you touch the tubes coming out of the heater core, or if you cut them or if you pull on them or anything like that, guess what? You got yourself a heater core leak. So what I did is, after the second heater core that I had a problem with, see if I can show you here. No, I'm not going to grab that here. Anyways, what I did is I cut the heater core tubes way back inside the car. Then I took some 5/8 hose and I ran them to the heater core and then double clamped it. Alright, double clamped it. And then I put these 90s on here. And I double clamp everything because you don't want no antifreeze going in your car. And so now, when I go to take the valve covers off the motor, because I run full roller lifters, I don't run no hydraulics, full rollers, I don't have no problem. And I can grab these and move them around. They move around a little bit and won't mess up the heater core. That's just one of many things that I'm going to show you guys. One of many things. But I just wanted to give you guys a glimpse of what's happening here before we get into. Here's the battery. See that battery there? That battery fits wall to wall. I don't know what the cold cracking amp is on it, but it's big. It's 745. So it's the biggest battery you can get in a Mazda Miata, right there. D5100. And they got ones that have the posts on this side and ones that have the post on this side. So this one has a post on this side. I ordered the wrong one. Get the one with the post on this side. So if you order this D5100, make sure you order the one with the post on this side. That way this is easier to connect. See how it's kind of stretched out? So that's just, like I said, I'm going to show you guys all kinds of stuff that I've learned along the way. Okay, so this is lug nuts on here. I was telling you about the axles from the drive shaft shop. Okay, they got ARP studs on it. The hubs are made out of chrome moly. The CV joints and the axles, when I show you guys, you're not going to believe it. You won't believe it. They're indestructible axles. They're $2,000 for the Parado, like $1,800 and something dollars. But that's just, you buy the axles, you don't have to worry about it. It's just something you put out of your mind. Anyways, these are titanium lug nuts. I was having problems with lug nuts. These lug nuts are actually made out of titanium. So I had aluminum ones on there, and they're stretching and coming off and doing all kinds of stuff. So these are titanium lug nuts. But I'll give you the part number on the titanium lug nuts. I'll give you the part number on it. I'll give you everything that I know. Tell you everything about it. So anyways, back to this discussing the mains here. Okay. When you're get your block from wherever you get it from, and you're having your mains home, that's if your block passed the X-ray, because they're going to X-ray your block, make sure it doesn't have any cracks in it, and all kinds of stuff they're going to do to your block. So you want the block mains line home. Okay, so you got to call it cleveite, or you could just tell the guys, well, I like the mains honed on it. Then they're going to put it to wherever they want it to. Wherever the guys that are honing your mains are going to put it to wherever they want. You don't want to do that. You want to give them an exact number to hit on the mains. I'm talking about the inside diameter of your mains on your block. Let's pretend for a second that the crankshaft's not in here. All right. Pretend for a second the crankshaft's not in here and the bearing's not in here. This is your mains, 1 through 5. This inside diameter that they're going to do the hone lining to, all right, this has to be a certain dimension. When the caps are all torqued down, if you got a 302 block, whatever Chilton's tells you to torque the mains to, that's what they have to be torqued to. And the guys that are honing your mains know this. They know this. They're going to torque those down. Hopefully, they're going to torque them down to whatever it calls for in the manual, depending on what your block you have, what kind of block you have. You know, if you got a Bill Mitchell block, and you torque it down to Bill Mitchell specifications. If you got a Ford 1968 302 Mexican block, then you torque it down to whatever it says in 1968 for a Ford 302 Mexican block. So they're all torqued down. So they have this machine. It starts over here. It starts at number 5. That's how the machine's hooked up. The machine's going to hone all your mains. It's going to hone it. You know, crankshaft's not in, bearings aren't in, mains are all torqued down. This is not here. We're going to pretend that the crankshaft's not here. So they're going to hone it. Well, if you don't tell them what specification to hone it to, they're going to put it anywhere, and you call it cleveite, they're going to hone that main to anywhere between 2.4412 to 2.4420. All right, anywhere in between there, that's where they're going to set the mains to. For me, myself, I want it set dead nuts in the middle between 2.4412 and 2.4420. I'm going to have them set it to 2.44175. All right, that's dead nuts in the middle where it's supposed to be. 2 inches, 2.44175. That's dead nuts in the middle. Okay. So what's going to happen is if they set these mains correctly, when you go and put a standard bearing in here and start doing your oil bore clearances, what's going to happen is that oil bore clearance, it falls in a relation of the inside diameter that they hone the mains to. I'm going to try to explain that a little better. What that means that, okay, say I'll take you for instance, I had a block that number 5 to number 1, it had a perfect 1/1000th taper in it. Number 5 being the big end, number 1 being the small end, okay? It had a perfect 1/1000th taper in it. It means that number 5 was exactly 1/1000th bigger than number 1. And it was a perfect taper. So when I went to put my standard mains in, standard bearings in, what happened is this was 2.5. And number 4 was 2 1/4. Number 3 was 2. And number 2 was 1 3/4, and number 1 was 1 1/2, because it had a taper in it, a perfect taper. So this inside diameter that they hone it to is, what happens is when you put your bearings in, they relate to each other. So if this is a 1/2 thousandth smaller than what it's supposed to be, when you go and put your main bearing in, it shows it when you put the main bearing in, you torque the cap, and you go to take your dial bore gauge reading and compare it to the number 1 main on your crankshaft, it shows it being a 1/2 thousandth smaller. So that's why it's so important for the mains to be the same. So if this is, if it ends up being 2.44175 and they're all perfectly 2.44175, they're all the same inside diameter of the mains, then when you go to put your standard bearings in, they're all the same. They're all maybe 1 1/2. They'll all be 1 1/2, or they'll all be 2. All right. So it's easier for you to do your oil bore clearances, or get your oil bore clearances for the block, if the mains are all the same. That's what I'm going to try to explain to you about it more in detail as I go along here. But I wanted to make that perfectly clear, that that's how important it is for the inside diameter to be the same on this. Same thing with your connecting rods. That inside diameter to the connecting rods, if one of those connecting rods is a 1/2 inch smaller, and when you go to put the bearings in, it's going to show up when you put the rod bearing in the connecting rod. It's going to show up being a 1/2 inch smaller. So it's real important to mic your connecting rods and your mains. You mic all your connecting rods inside diameter to see if the manufacturer made all the connecting rods the same. And if one's smaller, I guarantee when you go to put the standard bearings in, that it's going to show up being smaller on your oil bore clearances. This is the stuff that they don't tell you. This is the stuff that I'm going to tell you. So that's that's the deal. So the next video I'm going to explain more into detail on your main bearings and rod bearings, and being a standard bearing and an X bearing. I know it's a lot of information to take in, but I'm throwing a lot of information at you. There's going to be a lot of information that I'm going to throw at you guys. I hope I made it clear enough. I'm going to make it more clear in the next bunch of videos I make, and show you exactly what to do, on how to get your rod, connecting rod oil clearances correct, and your main oil clearances correct. It means that oil clearances is the gap between the crankshaft and the bearing. It's real important to get that. But it's real important to have the block right. It's like the foundation of the house. If your foundation of the house is crooked, the rest of the house you're in trouble. Well, this is where you start with. You start with the block. The block has to be right. Everything. This is where we start. Start the block. And then if the mains are aligned correctly, and your oil clearances are correctly, and then when you spin the crankshaft, it's going to be super nice. I mean, should just spin, no problem. Okay, so until I see you next time. Well, John again. I did also want to mention that there's always more than one way to skin a cat. It's the way it's always been. So I also want to give you this scenario too. Okay, this is back on the mains again. We're talking about the mains. All right, so remember I recommend to set the mains at 2.44175. Okay, so machine shop did what you told them to do. You set it for 2.44175. And you put a set of standard bearings in your block, you know, and you measured out your crankshaft and the oil bore clearance that you got. I'm just giving you a scenario. For instance, say that you got 1.5 thousandths for oil bore clearance on your mains, you know. So you mic'd out the mains on your crankshaft. You got a set of standard bearings in here. All your mains are torqued down to what they're supposed to be at. And you checked it with the dial bore gauge, and the dial bore gauge says you got 1.5 thousandths on all of them. You got 1.5. What you can do is you can take the block back to the machine shop, and it's what machinists will call, it's called loosening up the mains. So the mains are all set for 2.44 175, what you told them to set up, but you mic'd them all, and you need 1/2 thousandths. Now what the machine shop can do for you is the machine shop can put this block back on the machine, and you know, like they did before with all the mains torqued down, they can put it back in the line honing machine, and they can hone off an extra 1/2 thousandths on all 5 of the mains, because you're at 1.5 and you need to be at 2. I'm saying if you need to be at 2. What they can do is they put it back in the machine, give it another line hone, and take 1/2 thousandths off the line hole for you, and then you'll be at 2. That's how it works. Same thing with the connecting rods. You put your connecting rod bearing in the big end of your connecting rod. And if you're at 1.5, you want to be at 2, but you don't want to get the X bearings. Now I'm going to explain to you about the X bearings in the next segment. What they do is they'll hone the inside. They got a special machine that they put that connecting rod on. Special honing machine, and hones it, and they can hone the extra 1/2 thousandths out of the big end of the connecting rod, so that when you put your bearings in it again and torque the connecting rod back down, the 1/2 thousandths, it'll have 1/2 thousandths more clearance. That's how when you see the TV says, well, you got to take it back to the machine shop and they'll fix it for you. Well, that's how they fix it. I'm explaining to you how the machine shop's going to fix your oil clearance and your connecting rods and your mains. What they're going to do is they're going to re-hone your mains, line hone your mains. And if they're going to do it with a small end of the rod, they're going to re-hone the rods. But that means that they have to take your block, they have to set it back up in the line honing machine, and then they got to torque it all down, and they got to mic it all up again, got to see where they're at, and they got to hone it. And then after they get done giving you the extra 1/2 thousandths, they got to take it out of the machine. Then they got to take all the oil plugs back out of it again. And they got to clean all the oil galleries again. Then they got to hot tank your block again. They got to do all this work to it to get you that extra 1/2 thousandths. And if they charge you for it, I don't know if they're going to charge you for it or not. You know, if you get it done for free, well, we can have it done. But they might charge you another $200, $300, $400, whatever it is. I'm gonna show you how, and that's one of your options. In the next segment here, I'm gonna show you how I do it. So you can always do it any way you want to do it, but that's one of your options. You know, you can take it back. You know, you got to put the block in the car, and you got to take it back to them, and then they're gonna have the block for a week or not, or you know what I mean. And then they're gonna have to set it up in the machine again, go through the whole spiel. But they can do it. Same thing with your rods. You can take it over, and the rod's pretty easy to do. Connector rod's pretty easy to do. Block, that ain't so easy. But the connector rod, they just put it in the machine, you know. Put it on the machine, give you the extra 1/2. Nah, that's not too much of a big deal. But make sure you do all the rods. Don't keep handing them one rod at a time. You make sure that you get all your clearances that you need for the connecting rods, and tell them what they need to hone out on the big end of each connecting rod, so you don't drive the guy crazy. Or you can do it the way I show you with the standard bearings and X bearings, and I'll get to that in the next segment. But I just wanted to tell you that's another option that you can do. All right, see you soon.